Welcome. In this lesson, we'll explore basic machine learning concepts, which are foundational to understanding how AI models learn from data. You'll learn about different types of learning, machine learning algorithms, and how we evaluate models. Types of machine learning. There are three main types of machine learning. Supervised learning. Trains a model using labeled data, allowing it to make predictions based on input and output pairs. Example: predicting whether an email is spam or not. Unsupervised learning works with unlabeled data, identifying patterns and structures without predefined categories. Example: grouping customers based on purchasing behavior. Reinforcement learning teaches a model to make decisions by rewarding good choices and penalizing bad ones. Example: training an AI to play a game by optimizing its moves over time. Supervised versus unsupervised learning examples. Supervised learning uses labeled data to train a model to predict outputs. Example: training a model to classify images as cats or dogs. Unsupervised learning identifies patterns in unlabeled data. Example: clustering customers based on buying behavior for targeted marketing. Popular machine learning algorithms. Here are a few popular algorithms you'll encounter in machine learning. K-nearest neighbors, KNN. A simple and effective algorithm for classification and regression. It works by finding the most similar data points, neighbors, to the new data point, and using the majority class or average of those neighbors to make predictions. Decision trees. These are used for classification and regression tasks. They split data based on feature values to make predictions. Logistic regression. This is a classification algorithm that predicts the probability of a certain class or event based on one or more features. K-means. Clustering. A popular algorithm for unsupervised learning that groups data into clusters based on similarity. Evaluating model performance. After training a machine learning model, it's important to evaluate its performance using various metrics. Accuracy. The percentage of correct predictions made by the model. Confusion. Matrix. A table used to evaluate the performance of classification models by comparing actual versus predicted values. Precision, recall, F1 score. Metrics used to evaluate classification models in more detail, especially when dealing with imbalanced datasets. Getting started with code. To help you get started with these concepts, here are some examples of basic machine learning tasks in Python, using popular libraries like scikit-learn. Creating a k-nearest neighbors classifier. Training a decision tree. Splitting data into training and testing sets. Evaluating model accuracy. In this lesson, you learned about machine learning basics, including the different types of learning: supervised, unsupervised, and reinforcement, popular algorithms like KNN and decision trees, and how to evaluate model performance. Now that you understand the fundamentals, you can begin applying machine learning algorithms to solve real-world problems. Stay tuned for the next lesson, where we dive deeper into specific machine learning algorithms.